Good afternoon, our friends. We welcome you to at this session today with Dr. Abigail Perkins, and she's going to share some wonderful information about the work that our department has been doing on STEM labs. I'm going to hand it over to Dr. Abigail Perkins. Thank you, Abby.
Hello, thank you for the great welcome. It's nice to have everyone here for conducting STEM labs online. First, a little bit about myself. I love teaching labs. My MS is in physics. My PhD is in curriculum and instruction for science education, specializing in STEM 21st century education. So I am very delighted to be presenting on behalf of the Center for Online and Continuing Education today. The outline is to first have a reflection slide on your individual journey, what you ideally envision your lab to be. Then we will discuss the state of the state post summer, post spring. Where are we now? We've all been through a lot. What are some of the salient silver linings from having gone through COVID? And the remaining portions will focus on implementation of strategies, tools. We will provide some tips. And then we will be concluding with the services that we provide to assist you in attaining cohesion for delivering and designing your labs. So, what are your lab learning goals? Do you want to have your entire lab online? Do you want to have your lab staged in parallel with online and a face-to-face component? Do you just want a few activities, maybe one singular activity to help and augment what you currently have? Is your lab an introductory lab or an upper level lab? These are dependent on how the lab would be designed. There are forms of interaction for successful um, lab design and delivery. Specifically, there's the technology interaction, there's the student to student interaction, and there's the student to instructor interaction. How would these three main types of interaction support your lab learning goals? And then we have levels of immersion. We have low level technology use, and then we have higher level. So for example, lower level would be more simple simulations. Higher level, we have VR headsets and um, more en- highly engaged, highly immersive components. So these are all elements to consider when reflecting on your learning goals for your lab.
Abby, Dr. Raymond has said that one of her goals is to have her labs accessible to diverse learners, which I think is probably a goal for all of us. And she also is hoping that your references will be included in the follow-up, which I'm sure it will.
Oh, I have 3 pages of references, and I
Wonderful.
thank you for that question. All virtual reality, augmented reality, extended reality developments have a platform based on a foundation of universal design, of accessibility as the primary component before anything is developed. Everything is rooted in universal design, and that is an agreed upon standard in AR, VR, extended reality development for higher education and all forms of education. So that is of utmost importance. Thank you for bringing that up.
And I will also add that Michelle Papania has said that as a part of her personal goals are to have student to student and student to instructor interactions, which are part of that threefold active learning component. So yes, definitely a part of that, right?
Beautiful, beautiful, wonderful, wonderful to hear these. So let's reflect on the state of this state. We have been through a lot, and there are some actual salient silver linings that we have learned from our rapid transition to remote instruction. We have learned that open-ended labs seem to be more beneficial than closed labs. Videos and interactivities are leading benefits to student learning. They remain leading benefits to student learning. So for example, coupling videos with simulations or higher level types of immersion. And this requires a type of scaffolding that is reflected in domain norms as well as your personal lab goals. So weaving immersive online content together is supportive to a healthy online lab. There's video simulations in VR that we will focus on. For videos, the literature base indicates that 360 videos are realizable, they are attainable, beneficial, and scalable for various domains. Guided videos during COVID have also proven beneficial. One example in particular is an instructor can video live record themselves conducting a lab and have their students narrate and guide the instructor through conducting the experiment. And this is a way to scaffold up agentic participation. And then there are other types of engagement in that form where students help each other. For simulations, improve learner mental models through self-regulated interactions with real-time feedback. So the student can engage in a self-regulatory metacognitive manner. And simulations are particularly good for those STEM areas where there is an unobservable phenomena that needs to be modeled. And the simulations function outside the realm of physical doing and can access those unobservable events. Virtual reality harnesses active learning inherent to effective experiences. And we also want to go beyond active learning. So integrating immersive online content into our pedagogical design of instructional delivery of STEM labs targets how to realistically meet the needs of our students now. That is moving past active learning to include pedagogy for knowledge transfer to other labs, to the workforce, continued practical applications, and participation in the scientific community. Other lessons learned from COVID, student cohorts have worked for collaborative data collection and analysis. So there's one cohort, for example, that is face-to-face, another cohort that is online, and those two cohorts communicate together using different learning objectives, and they communicate through different forms of technology. Lab remission has also proven to be very beneficial. Having a half an hour for everyone to communicate, engage, talk to each other online so the different cohorts can reflect with one another and just have that opportunity to reflect. Engagement, agency, and communication were reported as being more valued than grades during COVID. So these are all very interesting and important lessons that we have learned from COVID. So next, a glimpse into the state of the state here at FAU. We are doing authentic research in authentic lab environments, attainable through online instruction. In many cases, there is more attainable through online instruction. There are opportunities and more doors that we have realized have opened since COVID. There are varying levels of agency that we are able to pedagogically target that better align with the learning objectives for a more student-centered experience. And these varying agentic levels of immersive online content can be utilized differently for your specific domain. So for example, engineering and computer science would have a different layering of the interactive components than say a traditional physics lab. And that is an example what you just saw of FAU's state of the state, what we are currently working on. So how do we scaffold all of these options? We are focusing this presentation on video strategies, simulations, and VR. There's a lot we could focus on, but specifically we're going to focus on video strategies first. And what you did see in the video that we just shared is a video tool for 360-degree cameras, and this allows the student to explore and go into the environment and have that exploratory freedom as if they were really in the lab, but in a safer way. Um, 360 is increasing in use throughout higher ed and throughout education in general. Their use and function. It's transferable. So this can be used across domains for different types of learning objectives. It integrates well with other immersive online content, and the levels of enhancement are adaptable to your course needs. What do I mean by enhancements? You can have callouts, you can have different features, you can have the question like you see in this picture here. You can have different types of questions. I'm going to go to a brief demo to show you what I mean here. So this is an example of an FAU online lab. So I am the student and I can move around, see what an actual lab here on campus, what that looks like. I have some scaffolding as to what I am doing, and these are real tools that are used in the lab. And then we have a question. We can get some feedback, embed a video within. There are lots of opportunities here.
Abby, we have a question about the VR software and hardware available uh, through FAU for instructors for classes.
Ah, I do have a slide on VR.
Perfect.
Right, so I will address that when I get to that slide. Um,
Thank you.
right now, we are in the development of constructing the Innovation Hub, and the Innovation Hub will be able to target some of those specifics when that is more solidified. But I will make sure to address that when we get to that slide later on. So for another thank you for asking, because virtual reality that is here to stay for sure, and it has proven very beneficial, and sometimes even more beneficial than face-to-face learning in quite a few studies. So another video tool beyond 360 is PlayPosit. This is a video enrichment tool, and it is an overlay. It allows you to overlay interactive quizzes, discussions, commentary for any video, YouTube, Vimeo, your own video. So the video will be playing, and as at a teachable moment, you can have a quiz pop up, you can have a poll pop up, and this can help you assess where your learners are at, provide feedback to your learners. If they answer a question incorrectly, it can direct them to a different video, maybe a previous lecture from the last time that everyone met. And it could also give an image or a link to an instructional material. It can also be an opportunity to reflect, and it does not have to necessarily be assessment based. It can be a substitute for lab practicum and lab safety, which have been suggested in the literature as two issues for online learning in a lab environment. However, we do have options to rebut that claim, and this is a good example. The PlayPosit tool can substitute for lab practicum and lab safety. You can have that image feedback based upon quiz responses, like I was saying. You don't have to have necessarily assessment. There could be call outs while the video is playing to add an extra layer of content delivery. And then there's also a table of contents to help navigation. This boosts critical thinking, dialogue, engagement, agency, and inclusion. Our last video tool that I'm going to be presenting is on Flipgrid. It is another video enrichment tool. You as the instructor create a discussion, share the discussion. Students create their own videos based on whatever prompt you would like, and then they share their video. The applications are to help communicate to each other the process, for example, of doing science. I'm going to have a real life example here. In a material science lab where there is an A cohort and a B cohort. The A cohort was face to face, the B cohort for this particular lab was online. And the B cohort, the online cohort, they coded what was needed for the face to face cohort to do the actual conducting of the experiment with the physical 3D printer in this example. So those two different cohorts needed to communicate to one another, and they used Flipgrid to um, not only communicate, but to also provide feedback to each other when they were flipped and the other cohorts were in the lab and then the other cohort was online. So they were noting to one another, oh, there's this one thing you need to look out for when you're doing this type of coding, or there's this other thing you need to look out for when you're at the physical printer. This button looks like it might be this, but I thought it was so and so. And so it's like a journal for students to communicate with one another. This, I just gave an example of this, is applicable to chunked group collaboration. It is also a substitute for lab practicum and lab safety assurance, and it's fun also. We are done with the video strategies. Now on to simulation strategies, unless there's any questions.
Not yet.
Okay,
We've
simulations.
addressed them.
So I'm not asking for our attendees to capture everything. I just want to give you a glimpse into some resources that are available. FET is a phenomenal repository for resources on simulations, and they give learning objectives for all of their simulations. Here is one that would be applicable for a physics lab. You have the learning objectives, and then students can play around and move these two different the plus and the negative. They can move those around and see how the equipotential lines change. So this could be embedded and scaffolded into your videos, your written content, to not just replace a face-to-face lab, but to enhance a face-to-face lab. Another example of a simulation that is useful is the Wolfram demonstrations. This is a global repository. All of the domains that you can imagine in higher education are in Wolfram. This is Mathematica based, and what I want as a takeaway for this slide is to just see you have a graph, and those two dots on the graph move in accordance to the changes of the solvents in those two barrels. So this is an example of how students can get real-time feedback. And now to extended reality strategies. Extended reality is an umbrella term for virtual reality, augmented reality, and anything in between. Virtual and augmented reality. So I have some links. I will send a PowerPoint to all the attendees after this, and everything that you see that is teal is a link. You will have access to these resources to explore on your own. This AR VR expeditions link will take you to the homepage for Google AR VR expeditions, and it is all for education. Some are pre-made, and you can use them for teaching photosynthesis, and there's different scenes you can use. It's analogous to Google Maps when you go through the walk tour, and you're walking through one of you're trying to find a certain business, and you take the walk tour. This is analogous to what an expedition is, and you can, as the instructor, put different points in your tour that have different pieces of information. So for example, if you want to explore a cell, you can have that tour through a cell and then have little points, hotspots, that define salient components in that cell. So for virtual reality, I have a link to Google VR expeditions, and these are worthwhile exploring. I don't want to go into them too detailed for the presentation, as I know that we have varied domains here with us today. And then the same thing with augmented reality. We have Google AR Expeditions. Now these, the Google VR Expeditions link and the Google AR Expeditions link, those are repositories that are continually growing, and they may require some research and making sure that the link works, as it is a global communal repository.
And Dr. Abigail, I will also let everyone know that when we send this out, we will also send a link to the session that Denny did a couple of weeks ago that go into some of these too, so that everyone can try those out as well.
Uh, that would be wonderful. Yes, Denny did a fantastic job, and he went into detail of what Google offers as far as tours, museums, expeditions, and even explored some AR, where there is a dinosaur on a table and a forensic scene. So yes, that definitely is a beautiful counterpoint to this PD session. What you also see on the screen here is a template of a periodic table. And this, let's click on it. I'd like to quickly show you what this looks like. This is a raw example. So students can move this around, zoom in. Now you'll notice there's nothing in this periodic table. That's because we might be able to tailor it to your course learning objectives, your module level learning objectives. And we can do this by adding certain objects to the different zones of the periodic table. And this is just an example of a starting point of some ideas that can be implemented for online lab experiences. What I am going to do is I'm going to scroll down and show you. I know that this is okay to be sharing because we have a license of CC BY, and that means Creative Commons attribution. So we are free to use this and adapt it to any means that may be applicable to a specific learning objective for an online lab. Before I move on, are there any questions on the virtual and augmented reality slide?
There was one earlier. Did we answer your question? And that would be for
For virtual reality. So what we offer for virtual reality, um, that is dependent upon your needs. And I would like to take the opportunity to highlight the Innovation Hub, which is in development, and it will be in the Davie campus, and that will really highlight a lot of virtual reality opportunities there. For the time being, we do have resources available, and I would encourage anyone interested to click on the links that I will provide at the end of the presentation to explore more resources. And then I have a specific example regarding e-text and lab manuals that may also help target that. So let me also pause and take an opportunity to talk about what virtual reality means. There is a plethora of definitions of what is and is not virtual reality, what is immersive, what is not immersive, where's the boundary between a simulation, virtual reality, is there a boundary? The definitions are all over the place. So virtual, what in general, what is accepted by the literature base as what virtual reality in education means is a sense of presence in an augmented space. Having a sense of presence, whether it be a Google expedition where you are moving through a world, or the example of the 360 video that I showed, where I briefly navigated with my mouse and I moved through um, the recorded lab, the actual room that is the lab, and then I clicked on some hotspots. So those are considered virtual reality. Even simulations are considered virtual reality. They are on the lower end of the immersive spectrum, but they are also considered virtual reality. So this can vary um, in, in it varies on a spectrum of levels of immersion, as far as virtual reality goes. And those can be tailored to your individual needs for your lab, your domain, and your course as a whole. If there are any other questions after this, please do feel free to reach out. And I will also be reaching out to all of you with a copy of this presentation with all of the links, and I will also be available for further discussion. Data collection and analysis. Yes, this too can happen in an online lab learning environment. I'm going to go through a few examples of some tools and some tips and tools for data collection. Students can collect at home. Students can collect in lab. If they collect in lab, for example, there is that cohort option. The instructor can provide data to the students. Data can also be retrieved from global repositories, open data at CERN, NASA, NOAA, the National Science Foundation, Wolfram, which was an example of a simulation I showed in a previous slide. Wolfram has a really big data repository. Also, data.gov has a huge open data repository as well as tools to help with analysis. The Pew Research Center also has public data sets available, though for secondary analysis. So there are options, and I know that when students collect data at home, there can be limitations. There's also limitations when students collect data in the lab. So this really is a time to reflect on your pedagogical identity, what are the norms for your domain, and what are the objectives of your lab as a whole that you would like your students to achieve. There has been a lot of success for students in collecting data at home, using cohorts to collaboratively collect data in the lab. Also, even when the instructor provides data and then retrieved data from global repositories. These are all successful ways to go about data collection. And if there is an area, for example, regarding students collecting data from home, if for your specific lab and, or your specific domain, there are gaps in the learning, in the development and the learning process, if there would be gaps that would come about from students collecting data at home, then that can be augmented and supplemented and filled with a simulation, a lecture with some of those video tools that we discussed. Another VR option, such as a Google VR expedition. So there are ways to fill gaps that may come about when collecting data in non-traditional methods.
Hello, everyone from Quincy, Massachusetts.
Hello, how are you, Lisa?
And
I'm.
welcome.
Hello, Nicole. Hello, everybody. Hello, Dr. Abby.
Oh, ah, so wonderful to hear your voice.
I am so charged by this conversation. I want to thank you so much for providing all of us with information to obviously move us forward with just really robust online teaching and learning opportunities. So my question specifically is, it focuses on UDL. And we have very diverse student populations, and unfortunately, they're having to jump into the online classroom. And from my perspective as director of online learning here at Quincy College, we have a lot of ESOL students and students who academically really do struggle in face-to-face, never mind the online classroom. So I'm wondering if you have any information, repositories, sites that are specifically targeted for these diverse populations.
That is a wonderful question. Thank you for asking that. Yes, I do, and I can touch those in my references. One in particular that stands out is POGLE. And pardon me, I don't recall if that's .org. I can verify that though. I do believe it is pogil.org, POGIL, and it is a pedagogy for inclusivity and inquiry, and it's based on process over inner knowledge um, attainment. And it
Okay.
is also centered around it's learner centered, but it is learner centered through a collaborative community mindset. And so that definitely helps because it fosters um, different perspectives and values different perspectives. um, this is difficult. The times that we are in right now, they are difficult because we have to factor in very significantly the technological interaction that faculty have to experience and then students also have to experience, and that's extra cognitive load, is to try to figure out how to navigate this technological world. So, wow, so
Mhm.
one specific example that, well, in general, collaboration is very helpful. Collaboration is very helpful. There is one specific study that I can think of. I do not have it in my references, though I can provide it to you. But I'll also give a summary of how VR training with a headset has helped students with autism be,
Wow.
engage more, become um, more engaged in a learning environment. It's considered a training, but this is one specific example of how a VR headset, meaning it is a higher level of immersion,
Mhm.
uh, but it still can help a diverse population. There's another study where see Fox et al. 2020 lessons learned from the pandemic. Um, no, that's a different citation. Um, but that does discuss some of these concepts. Um, uh, oh, there are so many citations as you'll see in my
Yeah.
references. Yes, VR in general um, does help diverse learners because it allows for self-regulated learning and students to progress at their own pace. Though there is a learning curve in getting started, but there are specific studies, for example, with the autism study with the VR headset. And if I remember, I think Kaladensky is the author of that source. I will find that.
Thank
Um,
you.
I will find, and then also regarding screen readers, I just would like to point out that I have found a really helpful strategy in math equations is utilizing something called MathML, and that can be copied in from a source and pasted as text only into a Word file, and then it becomes screen readable. So
Mhm.
if you are um, making an OER, adopting, curating resources, and they need to be compiled into a centralized location or put into a scaffolded sequence woven into your course game plan. One way to take equations that are from all sorts of different formats and um, equation readers is to use MathML, MATH, and then
Mhm.
capital M, capital L, and you copy and paste, and you paste as text only, and this works by the software reading the HTML code that's behind the math, and it makes it fully screen readable. So anyone with a visual impairment or someone who just wants to hear if it's better heard, it's fully screen readable. So MathML has been really helpful.
That's great. Thank you so much.
Well, thank you for the for that question. That's it's a wonderful question, and
And do
definitely
we have any other questions that might have generated in that conversation? Okay. Know that you can continue to ask them in the chat, and we'll let Dr. Abigail move on.
For data analysis, we have tips and tools for data analysis. Lower level introductory type labs, Google Slides, or Microsoft Excel have proven to be helpful. I capitalized or because some of the formulae writing differs in Google Slides and in Microsoft Excel. So I recommend sticking with one or the other. Google Slides does provide the element of collaboration. However, there are resources that are collaborative that can then be used with Microsoft Excel in the form of a CSV file. And so these are two options for analyzing data, however that data may be collected. One specific example is Jupyter using a Python language as a notebook with a shell where the instructor creates a shell and then the students can see how data retrieved from, say, a 3D printer, data retrieved from some uh, uh, computer coding program or some microelectronic circuitry. That type of information can be then utilized in this collaborative notebook. And then I recommend the instructor using a shell first to show and model how you can create graphs, how you can create charts from this data. So students, they go to the lab, whether online, whether face to face, and then there's this data. What do we do with the data now? Well, you want to analyze the data and then continue to analyze the data based on your initial findings. And so with the shell you have that modeled for you, and then you can input the data taken from the lab. Often this is doable remotely, and the data can be analyzed using, for example, Jupyter with a Python language. I mean, that's just one specific example for any of the computer scientists or computer engineers in the room. There is also a free statistical analysis program called JUMP. It is a mini version of SAS, but it is free and it comes with a repository of data sets. And this is a elaborated version of Excel in that it is more statistical oriented. You have more options to dive deeper into multi levels of statistics and instead of simply a regression line. So it reflects the interface more of SPSS and of SAS and some of those more professional statistical analysis software programs. So JUMP is available as an online data analysis tool, and the results and the data sets can be shared collaboratively online also. Data.gov, this not only is a source for data collection, it also is a source for tools, depending on your domain, again, your personal pedagogical autonomy and identity, and the learning objectives that you have for your lab, whether it's the entire lab or whether it's just one part of an experiment. This is a really huge repository. So it would take a little bit of time for a lot of these sources that I provided. It may take a little bit of time to go through, take a minute or two to type in your domain in the search menu and press enter and explore. But these are all very valuable resources that I'm providing in in this session. So I do not expect everyone to take away all of the nuances, but I do want to be able to provide a robust chunk of references and resources for you to take back with you to your lab.
Dr. Abby, we have another question. Dr. Raymond.
Sort of my instructional design nightmare has been an anatomy and physiology lab, the online lab that I was working with. How do you make the inside of a cell, cellular structures, how do you make that accessible to students with visual disabilities?
My first answer is to go with alt text, alternative text, to it alt text would be the
Yeah.
same type of alternative text that a screen reader would encounter for an image or a figure in a traditional electronic textbook. Depending on the specific type of um, immersive content that we're referring to, there may be a different avenue in how to address that. Um,
Yeah.
are you talking about something aligned with Google Expedition and something with a virtual reality component to it?
I'm open to any suggestions.
Okay, any suggestions at all? I alt text I think is a very good option. I do know that Google Expeditions does strive to have UDL. And there
Mhm.
are a lot of simulations that also do the same. So we'd have to work with verbal cues. There are also a lot of anatomy and physiology, um, Google Tours, Google Expeditions,
Mhm.
and AR that are available. And so that there's
Mhm.
a lot. That's actually probably one of the biggest ones one of the biggest represented domains in
Great.
in those repositories. Yes, and as far as being screen reader accessible, I don't have a specific answer for you, except that I do know that Google does strive
Mhm.
to follow that protocol of having UDL at the foundation of all AR VR
Mhm. Mhm.
development. So I would love to explore this further so I can give you some more concrete, specific examples. For starters, I would recommend I'm going to move up here, exploring these links that I
Mhm.
have on the virtual and augmented reality slide, exploring those links. And each expedition has been designed differently, and they
Mhm.
have different licenses, they have different domains, and some also have different levels of UDL, and there
Mhm.
may be some already available.
That would be excellent. Thank you very much.
And I
And
well, thank you.
I'm going to step in and say, Dr. Raymond, I would like to have you help continue this conversation if we do a follow-up. Well, because both of you are interested in finding the answers to your question, as all the rest of
Mhm.
us are too. So, and I'm going to suggest to Dr. Abigail that perhaps we do a follow-up to this session because I know you still have information. Dr. D says he wants to add something on A&P labs. The inside of the cell might be conceptualized via 3D printing or 3D models with organelles differentially projected. That sounds like a perfect solution too. So I have a feeling we're going to be doing some connecting um, throughout about some of these fascinating questions, and then do a really an in-depth follow-up. And I'm sure others who are with us, who are in different areas, that may have an approach based on their uh, their their area of expertise that would be applicable. So I am going to suggest that we reconnect with Dr. Abby and do a follow-up session for this. Does that meet with everyone else's perspective?
Yes, it is 1 o'clock, so I will be sending these slides out. And as mentioned, there are a plethora of emails, or pardon me, of references, and then we
Yeah.
also have 2 links for further assistance regarding many of the questions addressed in this session. So thank you very much for attending, and please keep an eye out for a thank you email with the presentation attached and a little bit more descriptions of some of those last slides.
And an invitation to everybody to, as you do more in-depth search on this, to reach out to us and or Dr. Abigail, and we can kind of pull together something that takes it to the next level. Thank you so much. Thank you all for joining us. What a great and exciting session. What do I have to quote? I'm going to quote Dr. Lisa if I can get back up to her comment. She said, "My mind is spinning and I have goosebumps. This is wonderful."
Oh,
So we are, you do, you have invigorated everybody with your own excitement and enthusiasm and the things that you bring to us that in my mind are, who knew? Thank you so much, Dr. Abigail Perkins, and
my
thank all of you
pleasure.
for joining us.
Thank you, everyone. Thank you. Wonderful questions. Thank you.